Today, let us look at area of a triangle. Let us take a triangle ABC. Now, in order to find the area of this triangle, let us drop a perpendicular BM onto the side AC. Now, BM represents the height of this triangle and AC would represent the base. We know that area of triangle ABC would be equal to half times base times its height, or half times B times H. Now let us represent the sides of this triangle by small a, small b and small c, where small a is the side opposite vertex A, small b is the side opposite vertex B, and small c is the side opposite vertex C. Let us assume AM to be x. So segment CM would be equal to B minus x. Now let us look at triangle BMA. Since it is a right angle triangle, we can apply the Pythagoras theorem and write h square plus x square is equal to c square. Or we could write x is equal to square root of c square minus h square. Similarly, we could apply the Pythagoras theorem to triangle BMC. So h square plus b minus x whole square is equal to a square. Now here we could apply the identity a minus b whole square. Since our bracket b minus x already has a b, let us change the variables in our identity to p and q. Now we can see that p is equal to b and q is equal to x. Let us substitute the values in this identity. Now here, let us replace the variable x with the value we found out earlier, which was square root of c square minus h square. Let us simplify and take the square root term on one side and the rest of the terms on the other side. Upon squaring, we can solve for h. Once again, we can apply the identity p square minus q square. And once again, let us apply the identity p square minus q square on both the brackets. We can manipulate the terms a little and we see that the term a plus b plus c is recurring in our equation. Note that a plus b plus c represents the perimeter of triangle ABC. Let us call that as 2 times s. Let us simplify further and we find that h is equal to 2 upon b times square root of s times s minus a times s minus b times s minus c. Now we have the value of h in terms of the sides a, b and c. So we can find the area of triangle ABC by applying the formula 1 upon 2 times b times h. Now let us substitute the value for h. And we find that the area of triangle ABC is equal to square root of s times s minus a times s minus b times s minus c, where s is equal to a plus b plus c by 2, or it is half of the perimeter of this triangle. Now this formula for area of a triangle that uses the sides of this triangle is known as Heron's formula. Let us see how we can apply this formula to a few problems. Find the area of a triangle, two sides of which are 18 centimeters and 10 centimeters, and the perimeter is 42 centimeters. So we have a triangle ABC. Let us call two of its sides, A as 18 centimeters and C as 10 centimeters. Now we are given that the perimeter, or A plus B plus C, is equal to 42. Let us substitute the values for A and C and solve for B. We see that B is equal to 14 centimeters. Now the formula for the area of a triangle is square root of S times S minus A times S minus B times S minus C. Now here we know A, B and C, but we would have to find S. Now S is half of A plus B plus C, or 21 centimeters. Let us substitute the values and simplify. Let us prime factorize the numbers under the square root, identify pairs of prime factors, and we find that the area of triangle ABC is 21 times square root of 11 centimeters square. Let us look at another problem. Sides of a triangle are in the ratio of 12:17:25 and its perimeter is 540 centimeters. Find its area. Now we are given ratio of sides. So let us take a common factor x and let the sides be 12x, 17x and 25x centimeters. Now we know that perimeter is sum of sides of this triangle, which is given as 540 centimeters. So let us add 12x, 17x and 25x and put that equal to 540 and solve for x. We get x as 10. So we can find the values of A, B and C. Now that we know A, B and C, we can find S, which is A plus B plus C by 2, or 270 centimeters. Now let us apply the Heron's formula to find the area of this triangle. Let us substitute the values and simplify. We see that area of this triangle is 9000 centimeters square. Let us look at another problem. The triangular side walls of a flyover have been used for advertisements. The sides of the walls are 122 meters, 22 meters and 120 meters. The advertisements yield an earning of 5,000 rupees per meter square per year. A company hired one of its walls for 3 months. How much rent did it pay? So we are given the sides of this triangle. Let's call them A, B and C. Now we are looking at rent for 3 months. Now since the rent is per meter square, we could find the rent as area of triangular wall times rent per meter square. But we also know that rent is charged per month. So we could break it into rent for 1 month times 3 months. Now we are given that rent for 1 year is 5,000 rupees, which could be written as rent for 1 month times 12 months. And we can find the rent for 1 month as 5,000 by 12. Let us put this value in our formula for rent paid. Now the only unknown is area of the triangular wall. So let us apply the Heron's formula, find out S, and substitute the values. Let us form pairs of the numbers under the square root. And we find that the area of triangular wall is 1320 centimeters square. Now let us substitute this value in the formula for rent paid. And we find that the rent paid would be 16,50,000 rupees.